In this video, we're covering expanding and factorizing expressions. So expanding and factorizing are what we call inverse operations. This means they're the opposite operations. So like when you have plussing and subtracting, they're inverse operations because they're opposites. Dividing and timesing, they're inverse. In the same way, expanding and factorizing are inverse operations. So if we have something like on your screen, let me just circle it here in brackets. When we expand that, we multiply it out and we get something like this, 8y plus 20. Now the reverse, if we go from 8y plus 20 to 4 bracket 2y plus 5, that is called factorizing. So we're going to look at expanding first. So when you expand an expression, you multiply each term inside the brackets by the term outside. Now I like to use something called the arrow method to do this. So I'm going to rewrite our expression. And what you do is you draw arrows going from the front term to each of the terms inside the brackets. Now each of these arrows represents multiplication, right? So each of these represent a times. Now I'm just going to change the color of one of these to make it a little bit easier to see what we're doing. All right. So if I go to start to expand this, now I'm doing the blue arrow, so I'm going to write in blue here. We have 6y times 1. The next thing we have is we have a plus here, which means we're going to have a plus down here. So we get plus, and then we have 6y times 2y. So 6y times 2y for our bottom red arrow. And now we can just solve these like normal. So we have 6y times 1, which is 6y. We have a plus, and we have 6y times 2y, which is 12y squared. Now we're going to look at a little bit more of a complex one where we've got an extra term at the back there. Now because that term at the back is not connected to the brackets whatsoever, we do not need to involve it in our first step. So the first step is always to expand. Bracket 1. We draw our arrows. Now what we need to look at here is we have negative 3e times 1. Then we have negative 3e times negative 5e. If you want, you can put those in brackets just to make it very clear. And then at the back, we still have our negative 6e. Nothing's happened with that. We're just going to leave it at the back for now. Now we can start to simplify these down. So we have negative 3 times 1, which is negative 3e. We have negative 3 times negative 5e. Now a negative and a negative make a positive, remember that. So we end up with 15e squared, and then we have our negative 6e at the end. We now look for what we call like terms. So remember e and e squared, we consider them different. So we're looking for like terms. So we're looking for where the e's are. And I'm just going to draw a squiggly line underneath our like terms. So we can combine those and we get negative 3e take away 6e. So we end up with negative 9e plus 15e squared. Now we're going to look at factorizing an expression. So when you're factorizing an expression, you first find the highest common factor, or what we write down as HCF, for both terms. Now this is then placed outside a set of brackets. When we're trying to fill in the brackets, we actually divide the original terms by the highest common factor and write the answers inside the brackets. So we'll now look at factorizing these expressions. So the first thing we need to do is find our highest common factor. So I'm going to look at our regular terms first, our coefficients. So we're looking at 36 and 24. Now you don't need to do this all the time. If you can see the highest common factor straight away, go for it. I'm going to make a list of my factors for 36. Now these factors are 1, 2, 3, 4, 6, 9, 12, and 18. Now you may wonder, and also 36. You may wonder how I found those. So 1 times 36 is 36, 2 times 18 is 36, 3 times 12 is 36, 4 times 9 is 36, and 6 times 6 is 36. So that's how we find our factors. So we're now going to write down the factors of 24, and they are 1, 2, 3, 4, 6, 8, 12, and 24. Now to find the highest common factor, we go along and then find the highest number that is shared between both our lists. So in this case, it's going to be 12. So 12 is our highest common factor. In terms of the coefficients, we now look at our letters, our pronumerals, and see if there's any common letters. So both have the letter D, so I also know D is also a factor, a highest common factor. So now what I do with that is I write that out the front. So I'm going to rewrite 36D squared plus 24D. I know it's going to be 12D out the front, and I've got some brackets inside. I then go, well, what's 36 divided by 12? And that's 3. I then say, well, what happens when I cancel out one of the D's that I've removed? I have one left, so D goes there. I then go, what's 24 divided by 12? That's 2. I've taken away the D already, so I don't have to worry about it. Alright, so over on the side here, I'll write that. So 36D squared divided by 12D is 3. And then we have 24D divided by 12D equals 2. And you'll notice that those are the things inside our brackets there. So that's how you factorize. It doesn't need to be as long as what I've made it. If you can see the highest common factor, if you can realize by looking at that it's 12D, you can simply go to that step and rewrite it. You do not have to do the list of factors unless you can't see it. So here's another one. So I'm going to do this one without writing my list out. So just by looking at 6 and 10, I know we're going to have a factor of 2. So I'm going to write 2 out the front. Both have the letter T, so I'm going to write that. I do notice there's a negative out the front, so I'm actually going to pull that out as well. So what that means is, now instead of having a negative here, I'm going to go negative 6t divided by, so negative 6t divided by negative 2t, and that equals 3. And down here we're going to have negative, we're going to have, not negative, we're going to have 10t squared divided by negative 2t, and that gets me negative 5t. So I can write that in here. So 3, take away 5t there. And that's that factorized. That was the quick way if you can just see it. But remember, if you can't, feel free to use the list of factors. So to end the video, we're going to do a quick recap. So remember, when you're expanding, you're going from brackets to a full expanded expression such as 8y plus 20. There's no brackets involved. When you're factorizing, you're doing the opposite. You're going from a full 8y plus 20 into something that involves brackets such as 4 bracket 2y plus 5. So when you expand an expression, you're multiplying each term inside the brackets by the term outside, and I like to use the arrow method so I don't make simple mistakes. When you're factorizing an expression, you first find that highest common factor for both terms, and you can do this by writing your list of factors and then finding the highest common one. And then this is then placed outside the set of brackets, and when we go to fill the answers in the brackets, we divide the original terms by the highest common factor. These answers then go inside the brackets.